thermal fluid sciences experts. This is Pro-Ready Engineer.
Hello, this is Bassam Abdelnabi from Pro-Ready Engineer. I'm excited to share a new video series featuring industry cases. If you like what you see, please consider liking and subscribing. Take care and talk to you soon.
So what happens when a massive multi-million-dollar investment just doesn't work? We're going to dive into a case study today about an aerospace test facility that was completely stalled. You see, they needed way more power and a lot more flexibility for their testing, but the very infrastructure they relied on was holding them back. Let's break down how a simple misdiagnosis nearly tanked a major operation.
Okay, so the story kicks off with a huge expense. To handle these new higher flow natural gas tests they wanted to run, the client went out and bought a brand new $1 million gas compressor. Now, on paper, this thing was supposed to be the silver bullet, the one purchase that would unlock all this new testing capability they were chasing.
But it wasn't the solution. Not even close. Despite that massive check they wrote, the most important, most critical tests were still failing. They just couldn't hit the conditions they needed. The whole facility was stuck, and that shiny new compressor was just sitting there, unable to solve the one problem everyone thought it was bought for. And that is the central mystery we are unpacking today. And this brings us right to the first part of our story, the $1 million misdiagnosis. It turns out the problem wasn't at all what it seemed, and that initial assumption was a really, really expensive one. And here it is, the crucial point. The compressor itself was fine. It wasn't the issue. The client had zeroed in on one big, obvious bottleneck, but in doing so, they'd completely missed the bigger picture. This is such a classic case of treating a symptom instead of the actual underlying disease.
So this is where Pro-Ready steps in. But here's the thing. Their first move wasn't to go look at that new compressor. Nope. Instead, they looked at everything else. By zooming way out and analyzing the entire fuel supply system, they started hunting for the true constraints, the real reasons the facility was being held back.
And what they found, well, it was basically a domino effect of hidden problems. That main gas feed from the local utility, yeah, it was totally maxed out. The pipes snaking through the facility, way too small to handle higher flows or pressures. Even the physical layout of the site was getting in the way. And maybe most critical of all, the client wanted to test all these new fuel blends, like mixing in nitrogen or propane, but the infrastructure to even handle those fuels literally didn't exist.
So you end up with this massive disconnect, right? On one hand, you have what the client needed, ambitious goals for high-flow gas and advanced fuel blending. And on the other hand, you have the stark reality of their infrastructure, which could deliver, well, none of it. This was the fundamental gap that absolutely had to be bridged. All right, so with the real problems finally identified, it was time for a real solution. Pro-Ready came up with this really comprehensive three-fuel strategy. The idea was to completely overhaul the facility's capabilities right from the ground up.
And this solution tackled each problem head-on. First, to get around that utility bottleneck, they decided to bring in trailers of compressed natural gas, CNG. It's basically a mobile, high-pressure gas supply right on site. Second, for the nitrogen doping, they specified jumbo trailers, but this time paired with the correctly sized regulators. And third, for propane blending, they designed a whole new system with a storage tank and a vaporizer. This wasn't just a patch, it was a total system rebuild.
Now, to make that high-pressure CNG system actually work safely, you need this one key piece of tech, a depressurization skid. See, when you drop the pressure of a gas that fast, it gets unbelievably cold. So cold, it can actually turn back into a liquid, which is super dangerous. This skid reduces the pressure in multiple, gentle stages and even has integrated heating to keep the gas, well, a gas. It was the absolute critical enabler for the entire natural gas solution.
And the nitty-gritty engineering details like that mattered everywhere. For instance, with the propane system, you couldn't just use regular old pipes. You needed these specialized heat-traced vapor lines. Think of it like a custom-fit electric blanket for the pipes, making sure the propane stays a gas and doesn't condense into a liquid before it gets where it's going. It's a small detail, but it has huge safety and performance implications.
Okay, so with this multi-million-dollar blueprint finally in hand, the project moved from design to reality. And this whole phase was just about meticulous, careful execution, finding all this highly specialized equipment, and then ensuring a totally flawless installation.
And make no mistake, this was a monumental undertaking. The timeline alone shows you the sheer scale of this project. I mean, we're talking well over a year. After 6 to 12 months of just detailed design and sourcing all the parts, the physical installation itself took another full year. And all of that led up to this final, intense month of commissioning, where absolutely everything had to work perfectly the first time.
And the stakes during that final commissioning phase? Incredibly high. We are talking about hundreds of thousands of dollars worth of super sensitive test hardware on the line. One wrong move, one incorrect fuel mixture, and you could have literally destroyed incredibly expensive equipment and set the whole project back by months. No pressure, right?
So, to manage that massive risk, the commissioning strategy had to be meticulous. You don't just flip a switch and hope for the best. No, it involved painstaking flow and pressure checks and verifying every single safety interlock in the system. They even de-risked the whole thing by running the initial propane tests on a tougher, secondary system first, proving the concept before any of the primary, super-sensitive hardware was ever put in harm's way.
And you know what? All of that careful planning, all of that execution, it absolutely paid off. This brings us to the final outcome, where the facility wasn't just fixed, it was fundamentally transformed.
The results really do speak for themselves. The site could finally hit its target natural gas flow rates, completely bypassing those old utility limits. The nitrogen and propane systems worked exactly as designed, reliably and safely. But most importantly, all of this unlocked a whole new world of advanced combustion tests, stuff that was simply impossible for them to even attempt before. So the overall impact was just profound. This wasn't a repair job, it was a total transformation. A test site that was once limited and constrained became this flexible, future-ready platform, fully capable of supporting cutting-edge aerospace research for many, many years to come.
And this, right here, perfectly sums up the whole lesson. The key was to look beyond the obvious thing, that shiny new compressor, and to dig deeper to find the true systemic constraints. It's such a powerful reminder that in complex engineering, sometimes the real problem is hiding in plain sight.
Ultimately, every complex system, whether it's in a high-tech lab or just in a business, has these hidden limitations. So this story really challenges all of us to ask a critical question. What's the obvious bottleneck that we're all focused on, and what deeper, systemic constraints are actually holding us back from unlocking our true potential?